Saturn. It is the sixth planet from the Sun and approximately 9.59 AUs from the Sun. Saturn is classified as a gas giant composed of mostly hydrogen, which is 96.3% of the atmosphere, and helium, which is 3.25% of the atmosphere. Even though it is almost all gas, the core is a slushy mix of minerals such as iron and nickel. Hydrogen is highly flammable, and Saturn being almost all hydrogen raises the question, could Saturn blow up if there was a spark? Fortunately or unfortunately, the answer is no. This is because in order for something to combust, there needs to be oxygen, and there is almost no oxygen in the atmosphere. Astronomers found what Saturn is made of through a really cool process called spectroscopy, where they collect radiation from planets or other celestial bodies in a machine called a spectrograph that essentially identifies the source and composition of the source of radiation. This topic is very confusing, so we won't be going deeper. Saturn has 274 confirmed moons. The biggest is Titan, which is the 11th biggest body in the solar system. Saturn's most notable feature is its rings, which are just a large collection of relatively small ice chunks that orbit Saturn. These ice chunks are classified not as moons, but as satellites because they are not big enough to have a spherical shape but still orbit Saturn. Even though the rings aren't actually rings, there do seem to be 7 main rings. Astronomers have found most all info about the rings from a spacecraft named Cassini. In 2017, the mission ended because the rocket fuel needed to adjust course was almost all used. SSSBs are smaller solar system objects, which can be divided into 2 categories: comets and asteroids. We will talk about comets first. Comets, often referred to as dirty snowballs, are chunks of ice with debris from the creation of the universe. Whether you believe God sparked a Big Bang or He just created the universe through speech, there is no denying the fact the comets have very old debris on them. The orbit of comets has to be very, very eccentric for the main difference between comets and asteroids, the tail, to form. This is because the tail is formed when the comet gets close enough to the Sun for solar winds to blow off some of the dust and debris, creating the tail. Astronomers have found out this through the previously mentioned procedure of spectroscopy, which we won't be explaining again because that would be redundant. Asteroids are classified as SSSBs because they aren't big enough to be a dwarf planet, giving them a potato-like shape. That is why we will be using a potato to represent asteroids. Astronomers found out why asteroids are oddly shaped simply by thinking about it. They had already come to the conclusion that planets and moons and dwarf planets are spherical in shape because the mass made gravity pull everything equally toward the core, and the 3D object where everywhere on the surface is equal distance from the center is the sphere. So because asteroids are relatively small, they don't have enough gravity to give them that spherical shape. Asteroids are a lot like comets, except their orbit is not nearly as eccentric and does not form a tail. Also, if a planet gets too close, the asteroid will either fall into the planet or its orbit will shift, throwing them into the Sun.